So now we're going to introduce some special types of square matrices. There are three types: diagonal, triangular, and symmetric. But to get started, we'll talk about the easier, which are the diagonal and the triangular matrices. So here are the definitions. So a diagonal matrix is a matrix, so these are all square matrices, so a diagonal matrix is a square matrix, and all of the non-zero entries have to fall along the main diagonal. So, in other words, anything that's not on the main diagonal is necessarily zero. So a diagonal matrix, all of the interesting entries fall along the diagonal. So if the matrix has to be a square matrix, so all of the interesting stuff falls along here, everything else, these are all zeros. So that's what a diagonal matrix is. An upper triangular matrix is a square matrix such that everything below the main diagonal is zero. So now you have something like this. You have the diagonal, you can have stuff here, and then everything else is zero. That's what it means to be upper triangular. So all of the interesting stuff is on the diagonal or above the diagonal. And a lower triangular matrix is a square matrix where all of the interesting stuff is below the main diagonal and everything above is a zero. So these are all zeros. So those are three, well, whatever. It depends how you split them up, but you have diagonal matrices, upper triangular and lower triangular matrices, and there are certain subsets of the upper and lower triangular matrices. These are called strict upper and lower triangular matrices. So in either case, it doesn't matter if it's upper or lower, a strict triangular matrix is a triangular matrix, so that it can be either upper or lower. Such that the diagonal entries are also zero. So strict means that the interesting stuff is strictly, so strict means that the interesting stuff is strictly above or strictly below the main diagonal. So there's special types of triangular matrix. Oops. So let's just do a few examples. Okay, so quick, let's just look at the definitions here. So diagonal, upper triangular, lower triangle, and strict triangular matrices. Okay, so just some examples. So if you had a matrix like 2, 0, 0, 3, this is a diagonal. Because all of the interesting stuff happens along the diagonal. Identity matrix. All identity matrices are diagonal. So these are all diagonal. You can even have the zero matrix. This is also diagonal. If you go back to the definition of diagonal, it says a diagonal matrix whose only possibly non-zero entries fall along the main diagonal. So the definition of a diagonal says that if it's not the diagonal, then it must be zero. Anything that satisfies that. So as long as these are zero, it is diagonal. So what's all along the diagonal may not necessarily be interesting, but so these are diagonal matrices. So these are what diagonal matrices look like. So then let's so what do us like upper triangular? So it's upper triangular So it would be something like if you had a 1, 2, 3, 0. That's upper triangular. All of the interesting stuff happens on the diagonal or above the diagonal. If you had a 3 by 3 matrix, 2, 3, 4, 5, 6, 7, 0, 0, 0. So that's upper triangular. Strict. What does strict upper triangular look like? Well, it looks exactly, well, it's similar to what's above, but you can't have anything on the diagonal matrix. So a 2 by 2, it would just have something there. I'll call that an A. So that's, so just something there. That's the only way you can have a strict upper 2 by 2 matrix. There's something that, it could be 0, but goes there. Or if it's a 3 by 3 matrix, you'd have to have 0. All of these would have to be 0. You have to have zeros along the main diagonal, and then all of the interesting stuff can only occur right there. So that's what strict upper triangulars look like, and similarly for lower triangulars. So lower. Same idea, so you could have something like a 4, 7, so that's lower triangular. All of the interesting stuff is along the diagonal or below the diagonal, lower. Or a 3 by 3 thing, you know, you could have 5 minus 7, 3, 2, 4, 6, 0, 0, 0. The important thing is that those have to be zeros. So these are lower triangular matrices, and then examples of strict lower triangular. It's the same idea. If it's like a 2 by 2 matrix, then the diagonal and above the diagonal has to be 0, so you could have something there. Or if it's a 3 by 3 matrix, the diagonal and everything above the diagonal has to be 0, so you could have something like this. So these are just examples of these special types of square matrices.